At first glance, spacewalking appears to be a serene, slow-motion ballet. Nothing could be further from the truth. Every spacewalk is literally a matter of life and death. Floating high above the Earth, spacewalkers travel at a speed of 18,000 miles per hour. At any moment, a micrometeorite or piece of orbital debris could slam into their spacesuit, ripping open their only protection against the lethal vacuum of space. How do you prepare for the possibility of being literally lost in space? How do you train for such a dangerous profession? And what is the experience of spacewalking really like? The place, the Kennedy Space Center in Florida. The event, the return of a space shuttle to the place where all shuttle missions begin.
This view of the heads-up display.
Late in 1999, 7 astronauts had a difficult assignment. Here, a critical mission to the Hubble Space Telescope involving 3 dangerous spacewalks ended.
Runway 33 at the Kennedy Space Center, completing a 6.5.
This is where it took place. The Hubble Space Telescope is unlike any other celestial observatory. Floating high above planet Earth, the images it collects have time and again helped redefine our understanding of the universe. But in December 1999, Hubble wasn't collecting any images. The failure of its onboard navigation system forced the space telescope to power down. The only way to bring Hubble back to life was to replace its broken gyroscopes. And the only way to do that was with a series of dangerous, exacting spacewalks. Officially, they're called EVAs, extravehicular activities.
Good job, Wayne.
But they're better known as spacewalks.
Put a lot of effort into that bag, but let's see. Yeah.
Awe-inspiring and dramatic,
I will.
they are also dangerous.
Oh, they got all kinds of fault lights on over here. Let me power cycle it. Okay.
The flight director says get back in.
Okay.
So far, training, skill, and luck have prevented any EVA disasters. So far. The complex tasks assigned to the Hubble repair crew required 3 separate EVAs, taking place on 3 consecutive days. 2 of the spacewalkers were veteran astronaut Steve Smith and EVA rookie John Grunsfeld.
The first EVA is, in some sense, the whole reason, the whole purpose we're going up on this mission is to replace 3 gyro units. And each gyro unit has 2 gyroscopes in it, called rate sensor units, RSUs. And it's a neat EVA because we get to open up the doors that house the primary scientific instruments, and as an astronomer, I'm very interested in that. And we get to go right into the bowels of the telescope and look around and, of course, be extremely careful. That'll take most of the EVA day, that first day. And it's just a very delicate operation. The gyroscopes themselves are somewhat fragile, but everything surrounding us, as Steve and I work inside the telescope, is very fragile.
The crew trained for months, preparing for the challenges that awaited them in space. The key to this mission, the key to every spacewalk, is the EVA suit. A product of years of research, it's all that separates spacewalking astronauts from certain death.
The spacesuits themselves are just fantastic machines, very, very clever. You have a big backpack on, and of course you're in a self-contained suit with a big bubble helmet. And for all practical purposes, you're a spaceship. You have your own pressure system, your own cooling system, your own power system. In the air control system, there's a box of chemicals that scrub the carbon dioxide that you breathe out of the system so you can stay in longer. It has a little computer that controls all of this, a series of valves that you can operate to change temperature or turn things on and off. So you really are a spaceship, and your connection to the orbiter once you're out there is only to keep you attached to the orbiter in case you let go and float away.
Hey, John, once again, you are tethered, right? I'm tethered to the V-ring. Okay?
Beneath the EVA suit, astronauts wear a garment that looks something like long underwear. The major difference is a network of plastic tubes. Cold water, fed through those tubes, helps keep a spacewalker cool. Without this cooling system, an astronaut would quickly overheat and experience heat exhaustion, unconsciousness, and eventually, death.
We don't build custom spacesuits anymore. We actually have a room full of elbows and knees and shoulders and things, and we go build a spacesuit for the person that's going to wear it that particular day. We used to do that by lacing in sizing inserts with this black cord. Here I am at the upper leg on this spacesuit. And now we've changed this set of interlocking rings so we can add a new ring in very quickly, and the astronauts can do this themselves on orbit in the spacecraft. They just click it in place and then make sure the lock is in place, and that will not come off.
Contemporary American EVA suits are the descendants of suits originally designed for the Mercury, Gemini, and Apollo programs. Vacuum chambers were used to test early designs. Researchers had to ensure that the suits would stand up to the unforgiving environment of space. These experiments were almost as dangerous as actually going into space. A 1966 test almost cost one man his life. Air was pumped out of test chambers, creating a nearly total vacuum. Test subjects were dependent on their spacesuit for life support. A suit failure was potentially fatal, something Jim LeBlanc discovered firsthand when a broken hose left him gasping for breath.
I tried to adjust the suit hoses by pressing on them because I suspected maybe one of those had blown off. And then I tried to report to the test director that I'd lost suit pressure. Of course, no air in the lungs, so nothing came out. And then I slowly started losing consciousness and stumbled back a little bit. And as you see in the film, there was a rail there that kind of a rest for the crew member, and actually toppled over and lost total consciousness at that time.
18,000.
Jim LeBlanc was at the threshold of death. In the low-pressure environment of the vacuum chamber, the saliva in his mouth was literally boiling away. LeBlanc survived this test, rescued with only seconds to spare.
The life support system on the back is more than just oxygen. That's important, but you've also got a cooling system to keep the astronaut cool, a way to remove carbon dioxide. You know, trees do that for us here, but we have a chemical inside the suit that takes care of the carbon dioxide, removes it, and then you rebreathe that oxygen. We've also got a battery for power, a radio for communications, and a computer and some other things, valves and switches and stuff. So it's much more than just a couple oxygen tanks.
It's amazing. I can feel the difference in warmth between the front side, the side, and the dark side. No doubt about it.
You can't think of space as having temperature because there's no molecules to vibrate, but things in space still get very hot or very cold. And your hands can get very cold if you're touching something very cold. And so we've got glove heaters now that are turned on and off by this switch on the glove. And the heaters are located in the fingers underneath the fabric here. They're powered by a battery through a cable that runs to the back of the spacesuit.